Yeah, see, this is right through present. Let's go through 2021. Let's look at 2011. You know, about this time in 2011. So the NAO was negative. Let's look at December. So you had some episodes of negative NAO in December, but look at this. Look how positive it was throughout the winter. All of winter, it was really positive, with some exceptions of it going neutral, like basically neutral. You know, going positive, 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 and then brief period of neutrality right in this area here. So this is here a neutral NAO. Sorry, not there. So basically from here to about here, you had a neutral NAO. You know, flirting, you know, even though it went negative, it did not go above 0.5. Anything above 0.5 or below 0.5 is negative or positive NAO. If it's flirting between less than 0.5, it's basically neutral. So we had neutral and positive basically for most of the winter. It did get a little bit more negative in February, but more neutral. And this is when we had most of our snowstorms. And of course, by March, it was basically too late, too little, too late. Yeah, we actually had a lot of nor'easters around this time. We had some snow, but it was too little, too late. And actually, oops, my bad. Let's look at the winter of 2012, 2013. You know, when Sandy hit. Yeah, very negative NAO. You had -2s. I mean, look at this. And then we had a blizzard right around, you know, this time, November 7th and 8th, you had a big snowstorm, right, as a transition was happening, and then positive, and then went back to negative, and yeah, we had quite a cold winter. We had a lot of snow, and, you know, remember, yeah, so you had a negative NAO, again, you know, greater than 0.5, -0.8, -1, -1, -9. So, yeah, you did have a pretty snowy winter, and the reason for that was because you had a negative NAO, and look at that. We're going to be trending negative for a while, so let's look at the PNA. Let's look at the AO first. Again, very negative, yes. Some of the models are trending negative. So yeah, definitely cold and snow potential. Let's look at the PNA. Probably going to be trying to trend up, right? Yep. Starting to trend up. Still negative, but it's trending up. But you're having a negative NAO, negative AO, and a negative PNA. Do you know what that means? You're going to have a very cold northern United States. You're going to have basically storms that are going to be crisscrossing the country. There's going to be a pattern similar to what we had back in 2010, late 2010, December of 2010. Let's look at that, right? Let's look at right. Let's look at the PNA, right? Nope, that's not what I want to look at. No, I don't want to download it. I want to look at it. There we go. Let's go on to 2020. Let's go to 2010, right? Late December 2010, right? So it's basically, let's see. You had a negative PNA. Look at that. Very analog to what we're having this year. So yes, this winter is going to be cold and snowy. Everything is pointing towards this being a very cold and snowy winter. See, the big snowstorm hit December 27, 2011. Look at that. You had a negative PNA. You had a negative PNA that was coming into a neutral, and this is what we're happening right now. So yes, there's the chance that we could have a snowstorm. I'm expecting, just looking at those teleconnections, there is a chance for a snowstorm late December. I mentioned late December, early January is going to be very snowy. That's what I said was going to happen. Look at that. Storm potential. Look at that. We're trying to go up the coast. You know, weather's going to go, bring us a snowstorm or not remains to be seen, but there is potential for a storm. Look at this. Cold air starting to come in. You know, storm could try to form. Let's look at the 18Z. Of course, not the most trustworthy runs, but So yeah, definitely snow potential late December, early January, as you're going to have a negative NAO, PNA starting to go positive. And so January, late December, January could be very stormy for the Northeast. I mean, a lot of your snow is going to be in the northern tier of the country. It's not going to be like, it's going to be more like north-south, like North Pacific Northwest, northern states, and the Northeast, like the interior Northeast is going to be very snowy. Coastal regions, with the oceans being so warm, New York City is going to be a wintry battle zone between snow and rain events. So, like, right along the coast, you'll probably be seeing rain because very, very warm ocean. I mean, let's look at those right here. Very, very warm. I mean, look at these temperatures. Sorry, this is looking at the Gulf, but still. Let's look at sea surface temperature anomalies. So let's go to Coral Reef Watch, and let's look at Atlantic. Let's look at the West, right? So let's look at zoom into the Northeast. Look how warm the waters are right off of New York. They're running on average between 3 and 4 degrees Celsius above normal. So this is very warm. It's like 5 degrees warmer than normal. Sure, a coastal storm could cool it down a little bit, but still very warm for this time of year. I haven't checked the coastal temperatures, but I'm going to check National Data Buoy Center, but I'm sure they're running somewhere in the upper 50s to low 60s. They've got to be somewhere like in the 50s at coldest, like no less than 50 degrees. Let's check the current temperature. This is going to be all in Celsius. If there is any water temperature, 51 degrees C. They are in the 50s, so any storm that goes along the coast is going to primarily produce rain, especially if you're having an east wind. If you're having a northeast wind, Eastern Long Island will probably be getting rain, and New York City could be getting a mix. I mean, if there's enough cold air and a coastal storm runs up the coast, and, you know, it's in trenchant cold air, you're going to have prolific snow events. So there is a chance, with all this warm water, if we're on the cold side of the system and there's enough cold air both at the surface and the loft, to get a major, major winter storm. And I'm talking about, like, feet of snow. It may or may not happen, but there's a chance we could get most of our snowfall in 1 or 2 storms this winter. Yeah, sure, you could get a couple, maybe weak snow events, because there's going to be a very cold potential with the NAO being negative, the AO going negative, and the PNA trying to, going from negative to positive. Like when it goes neutral, that's when you have your biggest chance of storms. However, I'm not sure about when those storms are going to occur. Like, I mean, how much we're going to get, but everything is pointing to it being a very cold, like, January. And I think there might be a January thaw. It's very common during La Niña events to have January thaws. And that will also bring the threat of severe weather once again to the south and maybe the lower Midwest, like the Ohio River Valley, like Kentucky. That usually happens during January thaw events and not during and usually it's not that severe. So I'm also taking, I'm currently on an antibiotic for a tonsil infection. So I'm going to have to get my tonsils removed shortly, within a week or 2. So I may not be uploading videos as regularly as I am right now. Like I've been more active, but because I have really bad tonsils right now, as it's becoming really painful for me to swallow food, the emergency room said I have to have a tonsil removal, tonsillectomy, and I'm currently taking clindamycin, which is one of the strongest antibiotics, because my tonsillitis has become actually dangerous. it's not bacterial, but this is due to a childhood of constantly having strep infections. That's why if you have recurring strep infections, you have cryptic tonsils, it's better to get them removed so they don't it becomes dangerous, because you could develop a peritonsillar abscess, which can obstruct breathing, and that can become fatal in some instances. So that's why it's important to get a tonsil that is inflamed, enlarged, removed, so that doesn't happen. Because bacteria, you can get a bacterial infection, not even strep, but something else. Like, I'm not a doctor, but I do have doctors in the family, and I actually considered becoming a doctor, but I ultimately decided to do meteorology instead, because, I also want to save lives, but unfortunately, medical stuff, for me, it's just not for me, because I don't have a very good stomach. I'm, very anxious, and I don't faint at the sight of blood. I don't have that condition, but I do have, I'm not very good with my fingers. I have tremors, so it comes from my dad's side of the family, so I cannot do surgery type stuff or operation, I could be I'm still considering maybe being a pediatrician or maybe a nutritionist, but with a PhD. I'm definitely considering getting my PhD in meteorology once I pass the hurdle of math and physics, which I never was able to take because of my disabilities and not going to going to high school. I went to a special ed school, and I already got into that, so that's not important. But now I'm trying to basically take the math and physics so then I can understand the meteorology. So once I have to do the mixing ratios and the conversion formulas, it'll be easier for me to understand both, meteorology 1, meteorology 2, because I understand the physical aspects of it, but what I'm having trouble understanding is the mathematical aspects, the formulas. I understand the physical aspects of it, but I also want to understand the mathematical aspects of it. So I could also do calculations and not just, because, computer models use calculations. And if I am to understand a computer model, I need to understand why it's thinking a certain way, why a computer model. Because once I could spot errors in the modeling, I could, point out because I've noticed that yes, you could spot errors also without mathematics. Like, if you have a good eye to the sky and you notice wind shear. Like, there was a time when there was a severe weather outbreak forecast, and I assumed that there's going to be tornadoes just because there was wind shear. But what if the cape wasn't high enough? What if the wind shear was there, but there wasn't enough cape, and the tornadoes wouldn't have formed? So the thing is, my forecast could have been off. The only reason I knew there was going to be enough convection was because there was a lot of convection in the morning when we had severe thunderstorms. And yeah, my forecast from June 1st, 2011 was spot on. I said Western Mass was going to get devastated by tornadoes. Eastern Mass, not so much. Eastern Mass was just going to get severe thunderstorms, but no tornadoes. Of course, my forecast panned out exactly as I forecasted, because my reasoning was that cool air off the water was going to inhibit convection. Exactly what happened. But still, what if my forecast was slightly off, and the amount of instability, the lack of instability that I forecasted was not as significant, and there was some tornadoes in Eastern Mass. That is why you have to look at the computer models. But also, you don't always trust the models. You also have to look at ground truth. That's why you have storm spotters who report the conditions, and they could also put that into the models. That's why we have weather balloon launches. So all that data could be factored in the models. That's why before a hurricane, or when there is definitely going to be a chance of a major storm, instead of doing two balloon launches a day, the National Weather Service, NOAA, does 4 balloon launches a day to more accurately feed the models. So yes, computer models, as necessary as they are not just the only factor in forecasting meteorology. For example, you also look at teleconnections, like what I'm looking at right now. I'm just basically giving a lecture about how to look at the models. For example, when you have a negative NAO, which I knew we were going to have because of all this warm water in Labrador and off the coast. I mean, look at this. Look at all this warm water. This is absolutely supporting of blocking patterns. I mean, look at this. Blocking pattern support. Also, a La Nina usually supports a blocking pattern. Usually. Yes, La Nina usually supports blocking pattern, but more neutral conditions. Because 2010, 2011, you had a very strong La Nina, but you also had a lot of warm water here, which in Labrador Straits, right here between Quebec and Greenland, and you had a very strong blocking because of that. Following winter, all water was cold. You had very little blocking, and therefore you had a lot of, warm air. You had a negative PNA. You had a lot of, warm air coming into the U.S., which is why the winter of 2011, 2012 was very warm. And I listened to Dr. Joe Bastardi, even though he does not agree in man-made climate change. He said, you have the PDO, NAO, AMO. That's what he said. He was talking about the PDO, how it has warm phases, cool phases. Atlantic has its warm phase, its cool phase. Yeah, right now the Atlantic is in its warm phase. But here's the thing. We were in the warm phase back in 2010. We were in the warm phase. But we flipped to cold phase. We were in the transitionary phase between warm and cool phase. But the thing is, this is the warmest I've seen it. Thing is, with every change in an oscillation like the PDO and the AMO, you're having a warmer phase with each cool and warm phase. It's getting warmer with each cycle because of climate change, because of global warming. I think we need to rename climate change again global warming, because the world as a whole is warming. We need to call it what it really is: global climatic global warming. That's what it needs to be called, climatic global warming. Because yes, you're having climate change. Yes, some areas are getting colder because of these oscillations, but these oscillations are usually what drives these weather patterns, right? But they're becoming unpredictable. Dr. Judas Cohen himself said that the correlation between high levels of snow in Siberia and cold weather here in North America is becoming very hard to forecast because of all the melting of polar sea ice and all the warming of the Arctic and the oceans. It's changing everything that we know, it's changing the cycles. Because back in 2018, when the Rycock volcano erupted in the Kuril Islands, it changed the weather pattern in the Arctic. It actually caused the polar vortex to get so strong that it kept all the Arctic air locked up over Siberia and Canada. And then yet in May, we had snow in New York. In fact, during the 1816 year without a summer, people in the northern United States said that winter was actually not very bad. It was a very modest winter, but there was snows in May, June, July, frost in August and July. So basically, the reason 2018-2019 winter had hardly any snow was as a direct result of the Rycock volcano. Largely to do with the eruption of the volcano, yes. And that's what my thinking was, and the eruption of Tambor in 1816 basically correlated that. So yes, volcanic eruptions, especially in the spring, early summer, would lead to a balmy winter, because, you would have a lot of sulfur in the stratosphere, which would warm the stratosphere but cool the troposphere, especially the upper troposphere. That would cause very strong polar vortices to form a very strong polar vortex, which would lock up all the cold air over the northern latitudes, but it would be cold for a very long time. So then in the summer, in the late spring, it would flood down, and you would have your snows in the winter. That is why, 1816 was like that. That is why we had snow in May May 9th, 2020, sorry, so Raycock erupted in 2019. It was June 2019, we had the eruption of the Raycock volcano right here. So that caused a very warm winter for the northern United States, especially the Northeast. But then we had that freak snow event that hit New York City May 9th. Why did it happen? Largely to do with the eruption of the Raycock volcano, which caused all the Arctic air to be trapped in the Arctic, which made the Arctic very cold and colder than normal. And then in May, it finally flooded because the polar vortex would tend to collapse around, if it doesn't collapse in the winter, it would collapse in the summer, in the spring. So that's why we had that freak snow grapple event and all that cold air flooding into the United States. The reason for that was the Raycock volcano, but also the Arctic that winter was very warm. So that was another reason. So if we do have a large volcanic eruption, say as a VI7 in the tropics, just like Tambora, and it erupts in the winter, or in the spring, you would likely have a warm winter, because again, polar vortex will be very strong. So you might have, I would say, an average, so slightly above average temperature winter. And then you would have, you might have a couple cold blasts. You'd likely have what I would call a positive NAO. You would likely have a positive AO. You might have a few drips, and you might have a few dips, but it also depends on what phase of the oceans are in too. And then you would likely have a very cold spring and summer. That's if you have a VI7 in the tropics or a high level 6 eruption. So the thing is, the reason for that freak snow we had in May was that eruption. And yes, I looked at the year of no summer. 1816 and froze to death. I think that's what it was called. Where's that video I was watching? Church. No, Vermont. Where's that video I was watching? There we go.
A house or a laptop? Which one do you think is worth more? Well, definitely not the house.
So let's watch that video. I'm actually, I don't know if you can see the
which
video.
I understand to be the oldest house in Bethel Village, and it has something.
Today in Across the Fence, a winter's tale. We'll learn about the events of 1816, or as that fateful year is known in Vermont, 1800 and froze to death. Find out what happened, how it happened, and why this church in Bethel is central to the story of the year without a summer.
Actually, I'm gonna...
Good afternoon, and thanks for joining us. I'm Keith Silva, in for Judy Simpson. Okay, we're all familiar with the old adage, if you don't like